Today we're going to be dealing with parallel and perpendicular lines for the second day. And the only task that we have today is to tell whether the lines for each pair of equations are parallel, perpendicular, or neither. So we need to obviously remember what that means. So parallel, that means when the m is the same, so when the slope is the same. Perpendicular, the m are opposite reciprocals of each other, okay? And neither just means that it doesn't meet either of those qualifications. Now, with these, one thing I want you to keep in mind, you can always graph these and see what they look like. I want to caution you though, just because they look like they're parallel doesn't mean they're actually parallel. Just because they look like they might be perpendicular does not mean they're perpendicular. So that is something that you still need to be able to look at the slopes of those two lines and figure out if they are parallel, perpendicular, or neither. So here we go. We have y equals 3x minus 8 and 3x minus y equals negative 1. The first one's already in slope-intercept form, so here we know that the slope is a positive 3 because it's the number that's always in front of x. In this second equation, we can't tell that yet. We've got to get y by itself. Now, there's lots of different ways to get y by itself. You could choose to move the x's and then divide everything by negative 1. You could also choose to move the y over and move the negative 1 over. That's up to you. So let's just keep going how we normally do, which means that we are going to move the x's first. So don't drop that negative, okay? That's negative y equals negative 3x minus 1. To get y by itself, we're going to have to divide everything by a negative 1, which means we would get y equals a negative divided by a negative makes that be a positive 3x, and negative 1 divided by negative 1 is a positive 1. So now that we're here, we can figure out that our slope for this one is 3. Looking at the slopes of both of those lines, they are the same. So these lines are parallel. The symbol for parallel is two lines that are at a slant there that are parallel to each other. So you could use either one. Okay? And all right, so parallel, those two lines are parallel. All right, perfect. So let's look at another one. We have 9x plus 3y equals 6 and 9y equals negative 3x plus 6. So we obviously have to do work for both of these. So I'm going to come over here and I'll draw a line. I'll kind of take them to their own sides here. So we have 9x plus 3y equals 6. To get y by itself, we need to move the x's. So that would give us 3y equals 9x plus 6. And then we're going to divide every single piece by 3. Negative 9 divided by 3 is negative 3x. 6 divided by 3 is 2. So here on this side, our slope is a negative 3. On the second equation, we have 9y equals negative 3x plus 6. So our job is to get y by itself. In this case, the x is already moved over, so we just need to divide everything by 9. So that would give us y equals negative 3/9. They both divide by 3, so that would give us negative 1/3. And 6/9, they both divide by 3 as well, which would give us 2/3. So that doesn't matter that that's not a nice easy number. To be honest with you, that y-intercept for these lines doesn't matter at all. We're just looking at the slopes. So here, our slope would be negative 1/3. So we're comparing negative 3 and negative 1/3. Well, we know they're not the same. Okay, they can't be the same because negative 3 and negative 1/3, not the same thing. For perpendicular, they would have to be opposite reciprocals. Okay, so if we take this negative 3, that would be negative 3 over 1. If we make it be the opposite reciprocal, so we would flip the fraction and we would switch the sign of it. So negative 3 to be perpendicular, the other one would have to have a slope of 1/3. Do we have positive 1/3? So we don't have that here, which means neither would be our answer. We know they're not parallel because they're not the same. We know they're not perpendicular because it's not opposite reciprocals. They are reciprocals of each other, but they're not opposites. Okay? So let's take a look at one more here. So we have 3x plus 2y equals -6 and -2x plus 3y equals 6. So here we do need to do work for both of them. So I'm going to go ahead and draw my line down the center there. You can kind of choose to do it however you want. So we have 3x plus 2y equals -6. We're going to move the x's. So that gives us 2y equals -3x minus 6. And then we're going to divide every single piece by 2. So -3 divided by 2. We're just going to leave that as a fraction. And -6 divided by 2 is -3. So here, our slope is -3/2. For the second equation, we have -2x plus 3y equals 6. So we can add 2x to both sides. That gives us 3y equals 2x plus 6. And then we're going to divide each side, or every single piece, by 3. So we get y equals 2/3 x plus 2. So here our slope is the 2/3. All right, we know they are not parallel because those two are not the same. But if we take our -3/2 and we find the opposite reciprocal, so reciprocal means to flip it. Opposite means we had a negative, so we're going to make it be positive. So -3/2 would turn into 2/3 for a perpendicular line, which is what we have. So here we would answer perpendicular. And you could also use the symbol if you wanted for perpendicular as an upside down capital T. Okay, so you must have y by itself in both equations in order to figure out the slope. And then you're going to look, are they the same? If they are, then they're parallel. If they're opposite reciprocals, then they're perpendicular. And if they don't meet either of those criteria, then it would be neither. And that's it.